Okay, so I said I think a lot of people don't. They took chemistry and they might even go to college, and but a lot of times they don't. I don't think they realize what that number means. So anybody want to try? Tell me, what do you think it means? You want to try it? Okay, I'm listening.
In the tiny world, it means like how many atomic mass units an
An
element has.
element, how many? How many atoms?
Yeah. Oh, wait, you said how many atoms? Just one.
Just one.
Yeah.
All right, so that would be the mass of one atom on the average in AMUs, right?
Right.
Okay, and there are no carbon atoms with that mass. That'd be the average, wouldn't it? Be like me hand a handful of jelly beans and say, well, the average mass is 5.011, but none of them weigh that, but that's the average. And what's the other note? What else does it mean?
Like so in the big world, it like talks about it means like how many grams of one are in one. How many grams are in one atom?
Really? One atom?
Or one molecule, right?
One molecule? We got molecules now?
Right.
And that's why.
Sorry, one mole.
So 1 mole of atoms. That's a lot of atoms, isn't it?
Right.
So how much would a mole of carbon atoms weigh?
12 grams.
What's the molar mass for carbon?
Yeah, would it be 12 grams?
It is, because the molar mass is the mass of a mole of anything, right? In grams. Okay, everybody got that? All right, so we got to think about, there is the little world, but what's neat is if we use a mole concept, whatever's happening in the world that I can do experiments in, like grams, I could go get 12 grams of carbon, couldn't I? I could see them. And if I did experiments and said, well, 12 grams of that reacted with 2 grams of that, that's what's happening in a little tiny world, like that. Okay, so if I found out that 1 mole of these, like 12 grams of that, would react with 32 grams of that, what would that tell me? Say, wait a minute, 1 mole of that, 2 moles of that, what would the compound be? Yes, that's great. That was fast. It'd be carbon dioxide, because you know what CO2 means? In the little world, it means 1 atom of carbon and 2 atoms of oxygen. But what does CO2 mean in the big world? 1 mole of carbon atoms will react with 2 moles of oxygen atoms. You see, it's just like a mirror. It's like a magnifying what's going on in the little world. You see that? So when I say CO2, it means 2 things. In the little world, it means 1 atom of carbon, 2 atoms of oxygen. In the big world, it means 1 mole of carbon atoms reacts with 2 moles of oxygen atoms. And God did that. I didn't do it. Okay, so let's go over here. Now, most of the homework you're going to do has to do with converting, okay? And if we're going to use factor label to convert things, we need equivalence. Now, I've seen all kinds of chemistry books. I've seen people that they have the mole wheel, and you can go online and see it on Pinterest. You'll see the mole wheel. There's many chemistry teachers that have tried to teach this a different way. My opinion is if you know factor label and you know how to write equivalence, you don't have to do any of that other stuff. You can read through your book and see how they did it. That's fine. They give example after example. You get that? But if you mainly say to yourself, if I know how to do the equivalence and I know factor label, then I won't be able to ever ask you a question that you can't convert. Everybody in here should be able to convert anything into anything here. So let's start out a little review, okay? If you are an element on the periodic table, you would say something like 1 mole of carbon equals, and that's always the same number, 6.02 times 10 to the 23rd, but what goes after that, that's important. The smallest piece of an element that still acts like that element is an atom. And then, now I don't need the periodic, I can do that in my, blindfolded, but I do need this one, I do need that number, and I get that from the periodic table, don't I? And I like to use 3 sig figs on these, that's what you can do, okay? So, for chlorine, you do 35.5, like that. Okay, now, anyway, so why don't we see if you could do one by yourself. Can you do one, let's pick Eloise. Ready? Eloise, do you have a periodic table handy? Give me the 3 equivalents for the element nitrogen. Let's do lithium. Go ahead and do lithium instead of nitrogen. How about that? As loud as you can, because you're in the back row.
Like 1 mole of lithium
Equals.
is 6 times 10 to the 23rd atoms of lithium, which is 6.94 grams.
Yeah, that's good. That's good. Did everybody got that? So I think everybody in here should be able to do that as long as you have. I always give you a periodic table. Yes, Claire.
So that one we should have rounded up to 7.
I'm okay with that one. That was so close to 7. I'm okay with that. The ones that are halfway, I would not round those. But that's a good question. Sometimes I use 7 for lithium. I like that. Good insight. I'll be all right with that. All right. Now we jump to the next thing, and we have these things that are not elements; they're compounds. And one kind of compound is a covalent compound. And what does that mean? What kind of compounds are held together with covalent bonds? What kind of things form covalent bonds with what other things? Yes?
Non-metals.
That's right. Is that right? Okay, so water would be one, and carbon dioxide, and C6H12O6. How about that? Aren't those all nonmetals? So what kind of bonds would they? That'd be covalent bonds, wouldn't they? Okay, so let's pick somebody. Will, you have a periodic table handy, don't you?
Yeah, I'm
Looking for your notes? Okay. Well, how about doing without notes? How about that? You want to try it? Okay, here, let's try. I'll give you a compound and see if you can do it. How about NH3? NH3 is called ammonia. And so give me the mole concept for ammonia. So like 1 mole of NH3, you help me out now.
So 1 mole of NH3
Equals.
equals
It's always the same number.
yeah, 6.023 times 10 to the 3rd.
6.02.
6.02 times 10 to the 3rd. NH3.
Well, wait, what are you going to put after that number? After Avogadro's number?
What did you say?
What's the unit? What's the name of that particle?
Ammonium.
What is it?
Oh, moles.
No?
Think what?
Okay, now this is important. Every year this happens, right? Some people they put the wrong label in the wrong place. You got that?
Oh.
But I don't want that to happen. So start again. 1 mole of NH3 equals. Keep going.
6.02 times 10 to the 23rd molecules.
Yes. Of NH3
Yeah.
equals.
Equals 17
Yes. 17 what?
grams.
Yes. Everybody get that? So really, and let's do the last one. So everybody okay on molecules then? So again, if it's a covalent compound, there's no difference between here and here, except the smallest piece of a covalent compound is called a molecule, isn't it? The smallest piece of water that acts like water is a molecule of water. All right, so then we just add them up. Like for water, we had 2 H's and an O. That's 16 plus 1 plus 1. That's 18. This was 12 plus 16 plus 16. That's how we got 44. And then this was O2. That'd be 16 plus 16. That would give you 32, wouldn't it? All right, is everybody okay on that one? All right, and the last one, ionic compounds. And those are made from what? What are ionic compounds made of? You already answered one. I'm sorry. Yes. Yes. Now remember, if they're made of ions, so most of the time the metal is the positive ion, isn't that right? And what's the non-metals are the negative ions, aren't they? And almost all of the polyatomic ions are what? Almost all of them are what? Positive or negative? Wow, really? What is it? Negative, weren't they? Wasn't there only one positive one? Maybe 2? And so they also are ions, aren't they? So polyatomic ions could be something like NaCl, but it could also be, let's try a new one. Is this your paper? Is this one we did for your class yesterday? Okay, let's try one more then. Let me get my pen out here. Let's see if you can do this one. 1 mole of Na, let's do Ba. BaNO3. I'm going to make it kind of hard on you, okay? See if you can finish that one. All right, I'll make it a little bit hard for you. 1 mole of barium nitrate, and see if you can finish the mole concept for barium nitrate. So if you have a calculator out, that helps. If you have a periodic table out, that helps. And then what we'll do is we'll practice a little bit of factor label here, and then I think we'll be done, ready to move on to something else. All right. Anybody ready? Everybody ready to do this one? All right, ready? Finley?
1 mole barium nitrate equals 6.02 times 10 to the 23rd. Formulate units of barium nitrate equals 279.3 grams of barium nitrate.
All right, before you're going to eat, Okay, how'd you come up with the molar mass there? Tell me-
Molar mass?
Yeah.
I took individually each of their masses.
How many bariums?
Barium is 137.3.
Okay, that's 1 barium,
1 barium, 6 oxygens, which are 6.
6 oxygen, so 2 times 3. So 6 times 16 was,
I just put it in the calculator.
all right, 96, okay. And then how many nitrogens?
How many nitrogens? 2 nitrogens.
2 times 1, right? See? So if you have nitrate, you could, another way you could do is find what nitrate was and multiply that times 2. Got that? Is that easier for you? So I know I had 1 barium, 2 nitrogens, 6 oxygens. Did everybody confirm it was 274? Is that what it is? 279?
I accidentally messed up.
Uh-oh. Is anybody not? No, nobody corrected that?
It's
That
261.3.
261?
Yes.
Okay.
I messed up. I switched.
Okay. So is everybody getting about 261.3?
Yeah.
I just made that up, so I don't know what the answer is. You had to confirm that with me. So if you had 1 barium and 2 nitrogens, 6 oxygens, then is that what you got, Todd? Okay. Well, you think about this. Now, really, there's no big difference here. The only real difference here is that what goes after Avogadro's number if you're an element? Atoms, right? What goes after Avogadro's number if it's a covalent compound? You say molecule, don't you? And what goes after Avogadro's number if it's an ionic compound? What do you do?
Formula units.
And I would have called them ionic units. I can't change it. So we're just going to say formula units because that's what the book says. See that? What do you think? Now, let's do one more factor label problem. How about that? I'm going to make one up. You see if you can come up with it, okay? Now, I'd like to give you some advice because we're just starting out here, okay? And even the thing you're going to take home, I'm going to give you some advice. Or if I give you a quiz next week, my advice. Until you get really, really good at this, my advice would be before I even start the problem, I'd write out the 3 equivalents. Get that? That's my advice for you. Let's go. Who have I called on? Claire. Hey, Claire. Give me the 3 things about the mole equivalent for glucose.
So 1 mole of glucose would equal 6.02 times 10 to the 23rd formula units of glucose.
Why do you say formula units?
Because that's not a,
What are these? Are these metals? Not, yeah, non-metal, non-metal, non-metal. What's going to be? Equals? Uh-oh. Now what are you going to do? So you got 6 times 12 plus. Does everybody know how to do this? 6 times 12 plus 12 times 1 plus 6 times 16. What you got?
180
Yes. 180 what?
grams.
Yes. Nice. Okay, now, my own opinion is, if you'll write out the equivalents first, you won't make that mistake that a lot of people make. Every year, some people want to put the word mole after Avogadro's number. What's that? When did that happen? All right? And some people want to put grams after Avogadro's number. Where'd that come from? The only 3 choices I've ever given you so far are atoms, molecules, and formula units, right? All right, let's try it. You always write down the given. Oh man, that's the powers of 10. What am I supposed to do with that? How many? How many's a billion? Okay, and that's C6H12O6. Whoa. Stop. Come back. Come back. That's weird. Okay. Okay, so anyway, if you'll write down the given, and by the way, this is molecules. I got interrupted, sorry. 1 times 10 to the 9th molecules of glucose, and what do? You multiply by a conversion factor. And is everybody okay on this? You say, how do I know which one to use? Well, what label do you want to get rid of up here? What is it? What label you want to get rid of up here? Well, what kind of molecules of glucose, right? And what do you want to replace it with? Moles. All right, please trust me. Every year, I've done this so many years, and I still have people that put the wrong numbers here. See that? You say, well, don't you make a mistake? Yes, but in this case, watch. Look at my equivalents. Where do you see molecules of glucose? No, yes. And so what goes there? What goes next to molecules of glucose? 6.02 times 10 to the 23rd. And what was next to moles? And I can't tell you how many times I see this. People want to put everything except what they should put here. All right? Can I ask, Julia, what goes here on moles? You say, moles? No. Oh, yes. What number? 1. That's it. Now, even though some of you don't understand how to do this now, right? Some of you are still going to miss this problem because of order of operations. So anytime you put a scientific number in the denominator, you should use parentheses. So when you say divided by, put parentheses and then 6.02 times 10 to the 23rd. Get that? And if you don't, you're going to get the wrong answer. All right, what do you think? Everybody get the answer? All right, find the closest neighbor and just hold your paper up and tell them what you got and tell them, here's what I got. What'd you get? See if you got that right. Man, 1 billion glucose molecules. How many moles is that?
Oh, shoot.
And if you don't match, talk to each other. Say, what? Here, look at Todd. Todd, you guys talk. What'd you get?
I got this.
Did you get that, Todd? You got that? Okay. All right, did you check? Here, check your. All right, now. All right, talk to Kieran, see if he got the same number as you. Well, this is the day. Hey, this is the day you want to find out. I said, I'm not sure how to do it. Here, you put this in a calculator. You say 1 times 10 to the 9th. Then you say divided by, parentheses, 6.02 times 10 to the 23rd. Enter. Is that what you did? Oh, 1 times 10 to the 9th. And then divided by 6, parentheses, 6.02 times 10 to the 23rd, sorry. All right, so, Isabella, what did you get? You confirmed this with somebody else, right? What is the answer?
I got 1.66.
1.66?
I don't think it's right.
Was there an E anywhere? Anywhere?
To the negative 15.
Wow. I don't know about that. I don't know about that. And you know what? If you didn't put parentheses when you divided, you'll be off by 46 powers of 10. I happen to know that 1 mole of glucose is 180 grams. I have a lot more than 180 grams. I've got to have more than a mole. You're telling me I only have a mole.
Okay, well,
So I want to try it again. Who'd you confirm that with?
okay. I actually got to the 31st.
Oh, wait. Okay. Wait, what is it?
10 to the
Did you really get 1.66?
Yeah,
Times 10 to the what?
31st.
How many people got that? Uh-oh. What'd you get, Finley?
I plugged it in correctly, and 1.66 times 10 to the negative 15.
There's no way.
It's molecules, right?
There's no way.
It's molecules, not grams.
No, this is moles, right?
Yeah.
I can tell you right now, 180 grams is 1 mole, and you have way, way more than 180 grams. There's going to be gobs and gobs of moles.
It said 180 molecules on 180 grams. It's not 100, it's 1 billion molecules.
Oh, my fault.
Not 100
Okay,
billion grams.
I made a mistake. Sorry. I thought I was doing moles. I gave you molecules, didn't I?
Yeah.
Ah, okay, that's my mistake. Sorry.
Wait, so what changed?
So what is the answer?
1.66 times 10 to the negative 15.
Negative 15?
Negative 15.
All right, how many people got that? All right, I made a mistake there because I thought I was going to start out with grams, and I started out with molecules. So good catch on that. Wait, well, first of all, I got to figure out why everybody's not getting the same answer. Did you guys get the same answer or not? Okay. Did you get the same answer? Yeah. Did you put 1 times 10 to the 9th divided by parentheses 6.02 times 10 to the 23rd parentheses and enter? Did you get this?
That's what I did, but I got to the 31st.
Or the 31st.
Did you do
I think it's 'cause they didn't.
Okay, let's everybody stop. Wait, start again. Everybody clear your calculator. Clear. Let's try it again. 1 times 10 to the 9th. Now look in your screen and see if it looks like, it might be 1E9. Does it say something like that? Or does it have the whole thing written out? 1E9? Okay. And then say divided by, parentheses, 6.02 times 10 to the 23rd. And then close parentheses, and then enter. But if we're not all getting the same answer, we got to figure that out.
Yeah, I got it to the negative.
So is this right? Okay, good. Hello. Okay, thanks. All right, well, anyway, what do you think?
Yeah, I did.
What do you think? What I'm going to do is, for the rest of the period, even though it's a homework assignment, you have quite a bit of time, and you'll get a lot of it done, okay? But the reason I want to do that is I want to walk around and find out, there are 3, 4, 5 of you that's still a little fuzzy on this. I'd like to help you before you take it home. It's no good. What if you take it home, you don't know what you're doing? You're going to have a tendency to just ask somebody else to tell them what you did, and that's cheating. So we don't want to do that, do we? All right, so let's go ahead. I'm going to give you a handout sheet, and I'll walk around, and you just work on it. And that'll be it for the video today.